Today we'll discuss about basic of Java collections, or in a 5 to 10 minutes you will get overview of most important keywords or most important feature of Java collection. Why we are using Java collections? There's in a Java we have a huge list of use cases or number of features. So today we are just focusing on collections framework or interface, specifically in Java, why we are referring that. So, what is Java collection framework basically, and why we are replacing with arrays? What is the important feature? So, as we are just focusing on important collections, Java collection interface, which hierarchy wise is a list, keyword, set, and map, and we mostly discuss about that only. So earlier we have arrays to store the information or data, but it's some limitation it has because it has limited fixed size. We can't add heterogeneous data like we can use in the one type of kind of data, and always we have to facing issue to handle the size or identify the size, so it's not dynamically at the runtime, it's not increase the size. So that's why we are replacing. So itself, array itself has some feature which is sometimes advantage for us if we know the size in the beginning or in initial while we are before the initializing or creating the object of array. But these problems or issues overcomes with the help of a Java collection. So all classes and interfaces related to Java collection are kept in the package of util package, and the all the list is like all the interfaces and classes are like list, set, queue, and map. So main feature are like we'll discuss about the list first. Here, list is just, so as we saw, list like we have a list of employees, list of students, list of books, right? So a list is sequentially collections of data. Like we are list of students, list of employees, and a list of uh, cars or bikes, right? So we have a sequential data, and element are might be positioning using the zero-based index. We are using sequentially order like from zero to and like how many numbers we have. So we are using sequentially raise numbers in while we are using list, and element can be inserted or removed or retrieved from any arbitrary order. So there is uh, like order always preserved in list, like first like always it's working in a LIFO uh, from based on index, and popular implementation of list is like ArrayList, vector, and linked list. So and some other internal list structural ArrayList, and internally use resizable array which grow and shrink, like we can add or delete the elements. So array list, while we implementing a list interface, then we can use array list class, vector, or linked list. They have itself some extra based on our requirement we can use. So array list internally used to resizable array which is grow or sync the data, delete or add the data wherever we want. Some same as array list, but it is a vector is synchronized. Array list is not synchronized, and linked list. So we can while we storing the data, each node is considered of three part, like reference to the previous element, value of the element, and reference to the next element. It's linked with previous and next element. So this is because they are linked. That's why it's called a linked list, and they are comes under the list, right? And another feature like null element, can we add null element in that? So in array list we can, yes, we can add array list in vector and linked list. Yes, in list interface we can add the null element, and duplicates are allowed in the list. Yes, so duplicates also allowed in all like array and vector and linked list. And another order of element. So array list is inserted order, and vector is also a like inserted order, and inserted like order is preserved in the list. So we have to focus on, like we have to remember, like order is preserved in the list. And another is synchronized. So ArrayList not synchronized. Vector is specifically designed for synchronization, and linked is also not synchronized. Performance-wise, ArrayList, vector, and linked list, as you here you can see. Okay, so mostly most efficient order as synchronized, similar ArrayList, but a little slower because of synchronization. Okay, now we come to the queue. So a queue is added data structure where the element are added from one or called tail to the queue, and element are removed from the another end of called the head of the queue. Okay, so it's popularly implemented priority queue, array queue, and like these are the classes and the queue interface. Okay, so actually queue is not that much uh, implemented or used, but yeah, that is also has a unique feature. So we have a priority queue, array queue, and linked list, and implemented list also. Okay. And here if we internal structures, array DQ internally uses resizable array to store the element. Null element is not allowed in the queue, and a duplicate element is allowed in the queue. Okay, so element are placed according to supplied comparator or natural order if no comparator is supplied. Okay, array DQ supported both LIFO and FIFO. So DQ like, and in which order it's inserted, that is supported, and it support both LIFO and FIFO, last in first and first in last out. Okay, synchronized, so both on priority queue and array DQ not synchronized. And next one is set. So set is basically used for the uniqueness of it does not have the duplicate inside that, and the set, it's just opposite of like set of uh, set of car, set of employee, set of bikes, set of mobile, set of laptops, means we don't have the duplicate inside in our set. So that's why we put that kind of data in our collection framework to inside the set interface to store that kind of where duplicate is not allowed. And set interface does not have the on method. All methods are inherited from the collection or in collection interfaces. It just applies restrictions on the method. Duplicate element are always avoided here. It has a popular implementations of set is HashSet, linked HashSet, or tree set. Okay, and structured HashSet internally uses HashMap. So HashSet internally use HashMap to store the element. Linked HashSet internally use the linked HashMap to store the element, or tree set internally use the tree map to store the element. Null element has set maximum one null element is allowed. Maximum one element is allowed in both HashMap and linked HashMap. And tree set doesn't allow even a single null element also. So in tree set, we don't it does not allow any single element. Duplicate elements we already covered, so not allowed as we have a unique set of data. So inside order, if we consider the order, so order is not preserved in that, and linked HashMap inserted order, insertion order is preserved. Linked HashMap insert in which order it is inserted, the same order is preserved. If we want to order also preserved inside the set, then we can use linked HashSet. and has set, linked has set, and tree set element are placed according to the supplied comparator or in natural order if no comparator is supplied. So tree set also preserve the uh, order using the comparator operator or natural order, or has set does not allow any. Has set has the one class has set which does not allow any order of the element. Synchronization, if we consider, then all like has set, links has set, tree set not are synchronized. Okay, and now most valuable or useful collection framework interface collects like interface of our collections is a map. So map is basically used to store key and value where key is unique and value is referred to a maybe duplicate. So keys does not have the duplicate, and data like the map interface is a part of Java collection framework but does not inherit collection interface. Map to store the data in a form of key value pair. Okay. Popular implementations is HashMap, linked HashMap, and tree map. Okay, so set also using the HashMap, HashSet, linked HashSet, and tree set. Okay, internal structure HashMap it internally use array of buckets where each bucket internally use linked list to hold the element. Okay, HashMap and linked HashMap is same as HashMap, but it is additionally use a doubly linked list to maintain insertion order of element. So in HashMap, it internally use an array of buckets. So in array we are using unique homogeneous data, and it in HashMap we have collections of HashMap where each bucket internally use linked list to hold the element, and in linked HashMap, it's a doubly linked each element inserted in the order. Tree map, it is internally used red black tree. Okay, null element HashMap only one null key and can have multiple null values. So in HashMap, we can use one null key and multiple null values. Linked HashMap, one null key is allowed. One and multiple null values are allowed. Tree map doesn't allow even a single null key, but even have the multiple null values, we can it is allowed. Okay. So only null values, one null values is allowed in a hash map and linked hash map. In tree map, no null values allowed. Duplicates. So HashMap doesn't allow duplicate key, but have duplicates values. Linked HashMap doesn't allow duplicates. Here difference null is allowed, duplicate is not allowed. Doesn't allow the duplicate keys, but duplicate value can be allowed. So duplicate like key or room number in a hotel room number 202 is assigned to any Abhishek, and room number 403 also assigned to Abhishek. So here Abhishek name is duplicate here, but key room number is different. Synchronized, so HashMap not synchronized, linked HashMap also not synchronized, tree map not synchronized. Performance wise and yeah, so here something tree map. Okay. So this is something about the basic of uh, Java collections. Here you can get some basic idea of most important keywords uh, for your preparation, for your daily uses, for your interview. You can use collections framework in a quick in 5 to 10 minutes. Thank you so much, guys. Let me know if you want to know more or if you feel something in this interesting something else in this video. Thank you so much.